Hello to all. So in this video we will learn about rate of change. So for rate of change, the rate of change of x is written as dx over dt. It means that rate of change of quantity x with respect to time t. In other words, when it comes to the word rate, it's basically based on time. So that's why we use the symbol of t. Next, problem related to the rate of change can be solved by using chain rule. So as we already know from topic 9, chain rule is one of the main important part for this topic. If you do not remember the concept of chain rule, please revise back topic 9, parametric differentiation. Next one, if the rate of change is positive, the quantity is increasing with time. If the rate of change is negative, means that the quantity is decreasing with time. So below are the guided steps to solve rate of change problem. So first step, we have to find two main information given in the question. First, the rate given in the question. And the second is what the question asks for, or rate that you need to find. That is the first main step. After that, we can proceed to step number 2, where you have to construct your own chain rule. After that, based on the chain rule, we can find the missing rate based on what you have constructed before. Then we can substitute the information given, and for final answer, do not forget to put the unit. So let's do some exercises. So we have example 8. A spherical balloon is inflated with air at rate of 200 cm³ per second. Find the rate of the radius of the balloon when the radius is 6 cm. Every single sentence provide info in order for you to solve this question. Okay. So our first step, as we mentioned before, is you have to find two main information. The first info is rate given in the question. So from the first sentence itself, a spherical balloon inflated with air at rate 200 cm³ per second. This is basically our dv over dt, and this is equal to 200 cm³ per second. Now proceed to the second sentence. Find, this is the rate that we have to find, rate of radius. When it comes to rate, it based on time. So basically we have to find dr over dt. I use the symbol r for radius when radius is 6 cm. So based on these two information, we now can proceed to our second step, where we have to construct our chain rule. This is basically just a tip. For our chain rule, for the first term, we put what we have to find. So the rate that we have to find here would be dr over dt. Okay, and then leave a space. Next, at the back, as our last term, you put the rate given in the question, and in this case is basically dv over dt. So from here, you can identify the missing rate that we have to find before solving the question. So just put what's connected from here. So from here, we know that we have to find basically dr over dv. So dr over dv, volume with respect to radius, and that's lead us to our third step. We have to find equation that relate volume and radius. So volume of a sphere is basically 4 over 3 pi r cubed. If we differentiate this equation, v with respect to r would be dv over dr equal to 4 pi r squared. Pi is basically a constant here, so it does not affect your derivative. Settle with the third step. Now moving on with the fourth step and our last step, we have to compute back this equation into our chain rule. So our chain rule just now is dr over dt equal to dr over dv, but we obtain dv over dr. Means that we have to flip over our equation. So we will have 1 over 4 pi r squared times with dv dt, in this case is 200. So we will get 200 over 4 pi, and then for the value of r given in the equation is 6, we can directly substitute it here, 6 squared. After that, you can compute this using your calculator, and our final answer will be 0.442. And don't forget to put your unit. In this case, we will have centimeter per second. Centimeter per second. Example 9. Water is running out of a conical funnel. So we have a shape of cone here at the rate of 1 centimeter cube per second. If the radius of the base of the funnel is 4 centimeter, means that our r is 4 and the height is 8 centimeter, means our h is 8. Find the rate at which the water level is dropping when it is 2 centimeter from the top. Okay, so step number 1, we have to find two main info given in the question. So from the first sentence itself, water is running out, means that we're gonna have dv over dt. Since it is running out, so we're gonna have a negative sign there of 1 centimeter cube per second. Now, based on the second sentence, find the rate at which the water levels. So we have to find our dH over dt when it is 2 centimeter from the top. So our original height is basically 8. If it's 2 centimeter from the top, means our H now will be 6 centimeter. So these are the two information given in the question. Now we can proceed to our second step, which is construct our chain rule. Same rule as before. What you have to find, you put at the front. So we have to find dH over dt. Rate given in the question, you put at the back. So we already have dV over dt. Means now we have to find dH over dV. So dH over dV is basically our volume equation with respect to height. Means that we have to use volume of cone. So proceed to our third step. We want to find our dH over dV. So based on the general formula of cone, the volume would be 1 over 3 pi r squared h. But now we have a problem because we have a r variable here. Because we want to find dV over dH, so we have to eliminate our r terms here. Based on the information given in the question, we can use the concept of ratio. So r over h is basically 4 over 8. Means that our r is basically h over 2. Now we can use this equation into our volume equation. So now our volume would be equal to 1 over 3 pi times with h over 2 squared times with h. So simplify this, we're gonna get pi h cube over 12. From here, we can directly differentiate our equation. So we're gonna get our dV over dH will be equal to 3 pi h squared over 12. Simplify this one again, you're gonna get pi h squared over 4. Okay, Now we can proceed to our last step, step number 4, substitute into our chain rule. So what we have to find is basically our dH over dt. What we already obtained is dH over dV. Sorry, we already find dV over dH, but we want dH over dV, so just flip it over. So we have 4 divided by pi h squared times with our dV over dt just now is negative 1. So we're gonna get negative 4 divided by pi. H given in the question is basically 6 centimeters. So 6 squared. And finally, our final answer here would be negative 0.0354. And our unit is basically, because it's height, centimeter per second. So now we proceed with example 10. 8-meter ladder raised against a vertical wall. If the bottom of the ladder is sliding away from the base of the wall at rate of 0.4 meter per second, how fast is the top of the ladder moving down the wall when the bottom of the ladder is 2 meter from the base? So basically now we have a situation here. So I think it's better for us to illustrate this in a figure. So let's say we have a wall, and obviously we're going to have a floor. So the wall I will assume as our y-axis and a floor as our x-axis. Now we have a ladder size of 8 meter and then rest against the wall. Okay. Now, if the bottom of the ladder is sliding away, means between the ladder and the floor sliding away. So I would say that is basically our dx over dt with the rate of 0.4. And then how fast is the top of the ladder moving down, means the movement between the ladder and the wall. So I would say that one is basically dy of dt when the bottom of the ladder is 2 meter from the base. Okay, so based on this, we can conclude for our first step, means that the question already give information about dx over dt, which is here is 0.4, and then we have to find dy over dt when our x is basically 2 meter from the wall. The second step, now we can construct our own chain rule. So what we have to find is at the front, so we have to find dy over dt, and then given in the question is basically dx over dt, means that in order to solve this, first we have to find dy over dt, sorry, dy over dx. So in order to find dy over dx, we have to find y in terms of x equation. So based on the figure below, we can see that we between the ladder, wall and our floor, we form a triangle there. So if I rewrite it back, we're gonna have 8 as our hypotenuse. Our height would be y and our base would be x. From here, basically, we can form a Pythagoras theorem equation. So where our y squared plus with 8 squared, x squared would be equal to 8 squared. Since we want to find dy over dx, means we have to rearrange so that we have equation where y is the main subject. So our y here would be equal to 64 minus x squared to the power of half. So now we can differentiate this by using power rule. So this will be half 64 minus x squared to the power of negative half times with negative 2x. Simplify this, we're gonna get negative x divided by set of 64 minus x squared. Okay, now we can proceed with our last step where we have to substitute back into our chain rule. So as before, we want to find dy over dt, rate of the ladder moving down the wall. So our dy over dx here is negative x over 64 minus x squared, and x given in the question is basically 2, so straight away I substitute 2 there. So we will have negative 2 divided by 64 minus 2 squared times with our dx dt in this case is 0.4. And then if you calculate this using your calculator, our final answer here would be negative 0.103, and our unit would be meter per second.